Welcome back. In this video, we're going to finish up section 7.4, which is about factoring using special formulas. And we had done the perfect square trinomials and the difference of squares in the previous video. In this one, we're going to look at the sum and difference of cubes formulas. So to do that, we need to talk about what perfect cubes are, because those are a little bit less familiar than perfect squares. So I made a table of some of the more commonly occurring ones that we'll need. So down the left column, we have n. The right column, we have n cubed. So we have cubes. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, and so on, all the way down. One thing that you'll notice that is different between cubes and squares is when you square numbers, you always get a positive answer. With cubes, you don't. -2 cubed is -8. -4 cubed is -64. So if you're less familiar with perfect cubes, you may want to jot down this table and keep it handy as you study and do your homework. So we have a couple of formulas for factoring sums and differences of cubes. And these we all, in all likelihood, haven't seen before. We saw in our earlier work that we had related factoring back to some multiplication we had done. And so those formulas were familiar. With these formulas, they're going to be probably completely unfamiliar. So let's take a look. We want to factor things that look like a cubed plus b cubed, or a cubed minus b cubed, a sum or difference of perfect cubes. And so we'll look at the structure and we'll see how we can remember this. So they're always going to end up being a binomial times a trinomial. That is, for a cubed plus b cubed, we have a 2-term guy times a 3-term guy. So a plus b times a squared minus ab plus b squared. So how to think about this is, if we're factoring a cubed plus b cubed, you're going to start off with a binomial that contains the two things that got cubed, the a and the b. When it's a sum of cubes, you'll have a plus. When it's a difference of cubes, you'll have a minus. Then you're going to have a trinomial, 3 terms, excuse me, and this looks a little bit like a squared minus 2ab plus b squared from the perfect square trinomial formula. But one huge difference is that there's no 2 in the middle. Perfect square trinomial formula had 2ab. In this one, it's just ab. Okay, so there's no 2. It still has a squared in the front, b squared in the back, but in the middle, it's going to be ab. And the other big difference you probably already noticed is the pattern in the signs. Let me make this red just for emphasis. On the sum of cubes, you're going to have a minus in this red position. For the difference of cubes, it's going to be a plus. Okay, so a way to think about the pattern is, in the binomial, it's going to be the same sign. For the sum of cubes, it's plus. For the difference of cubes, it's a minus. And then in the next position, it's opposite. For sum of cubes, we had a minus. For difference of cubes, we had a plus. In the back position, it's always plus. A mnemonic or memory aid for this that can help you remember this pattern is the word SOAP, S-O-A-P. You can think of that for standing for same, opposite, always plus. Same sign, opposite sign, and then always plus in the back. All right, so with that in mind, let's see if we can try some examples. We want to factor in this one, x cubed minus 100. 100 is not a perfect cube, so let me put on another 0, so it will be, there we go, x cubed minus 1,000. So we want to see this as a difference of 2 cubes, so we'll have x cubed minus 10 cubed. All right, so for the purposes of our formula, our a will be x and our b will be 10. So we should have a binomial times a trinomial. The binomial will just be the two things that got cubed. So it's going to be x minus 10. Okay. Then in the trinomial, we'll have x squared Then it was same sign, opposite sign. This is a difference of cubes, so we'll have plus. No 2, just the product of the two things. So 10x. And then in the back, the b squared. 10 squared is 100. We'll have 100, and then it's going to be a plus there. And that's it. Okay. All right. Make sure that you can see where we're getting each of those pieces from our formula. Okay, let's try that again. Y cubed plus 8. This is our first sum of cubes. Let me copy the formula down so that you can refer to it. There we go. So for y cubed plus 8, this is, of course, y cubed plus 2 cubed. So for the purposes of our formula, our a will be like the y, and our b will be the 2. So we have a binomial times a trinomial. The binomial is just the sum of the two things getting cubed. So here it's y plus 2. And then for the trinomial, it will start with the square of the first thing. We're doing a sum of cubes, so we'll have minus. Then there's no 2, but we'll have twice the product. We'll have just the product of the two things, so 2y. And then in the back, always plus, and 2 squared is 4th. Okay, there's that. Okay, u cubed minus 125. How many of these do we have? We have quite a few. Okay, u cubed minus 125. This will be u cubed minus 5 cubed. This will be a binomial times a trinomial. The binomial here will be just the difference of the two things that got cubed. In the front, we'll have u squared. In the back, we'll have 5 squared. That's 25. This was a difference of cubes, so we'll have plus, and then just the product of the two things, 5u. Okay. So how we can make this more complicated is making the a and b more interesting, perhaps in introducing some common factors. So we'll see examples like that. Here we've got 64 minus 27x cubed. 64 is 4, that's cubed, and then 27x cubed is going to be 3x cubed. So once again, binomial times trinomial. We'll have 4 minus 3x. The pattern for the signs is same, opposite, always plus. Okay, for the front of the trinomial, it's the first thing squared. 4 squared is 16. In the middle, we have the product of the two things, so that's 12x. And then in the back, the second thing squared, so 9x squared. You can reorder those terms in the second factor if you want. I think we should just leave it. Okay, let's try this next one. 25x cubed minus 64y cubed. So for this one, pause the video, take a minute, and try this yourself, and then restart the video and see how you did. All right, so this one is a difference of cubes. And so here's our formula. You can refer to it. So then our first thing is going to be 5x. Our second thing will be 4y. So we have 5x cubed minus 4y cubed. We'll have a binomial times a trinomial. Our binomial will be just the difference of the two things, 5x and 4y. This pattern for the signs is same, opposite, always plus. Then in the front, we'll have 5x squared. That's 25x squared. In the back, we'll have 4y squared. That's 16y squared. And then in the middle, we'll have the product of the two things. So that's 20xy. Okay, that will do it. In this one, what's interesting is we have a common factor of 4 that we're going to pull out first. So we have 4. This will give us 125x cubed plus y cubed. So our 4 will still be here. We'll have a binomial times a trinomial. 125x cubed, that's 5x in the binomial spot. Y cubed will be stay y. Then signs, same, opposite, always plus. In the binomial, or 5x plus y, so they started the trinomial, we'll have 5x squared, that's 25x squared. In the back, we'll have y squared, and then in the middle, 5xy. Okay. These things are kind of nice in that there's not a lot of writing to do. If you know the pattern, these can actually go by pretty fast. And I think that was our last example. So yeah, that takes us to the end of this section on factoring using special formulas. This part of the video, or this video, is specifically on the sum and difference of cubes formulas. That takes us to the end. Let me know if you have any questions, and have a great day.